Hey guys, this is problem 3. So the first thing you should note about problem 3 is that you have an odd geometry and you have an extra force at the end of your beam. Do not forget that you have this force which has both an axial and a shear component. So when you're calculating your principal stresses, even though you don't have any axial forces listed here on your diagrams in part A or part B, you still need to take into account for part D. So for part A, I'm just going to do a brief review on how to do shear and moment diagrams, because we're going to see this again and again and again and again and again. You guys are going to be drawing dozens and dozens and dozens of shear and moment diagrams, and the sooner you learn how to do them, the easier it will be on you, and the higher your grades will be later on. I know that Naveed and I, when we grade this homework set, this first homework set, if it's anything like it was last semester, we're going to see a lot of things that are meant to be shear and moment diagrams, but we have no idea what they're supposed to look like. Trying to decipher your shear and moment diagrams can be quite an amusing challenge. So whenever you have, let's just look at the case of a simply supported beam. You always just want to follow your arrows. So let's say that we have a distributed load here. I know that I have to have some reaction, right? And if I draw my shear diagram, I just want to follow the arrows. So when I'm going to start off at 0. This is a big arrow. I'm going to go up by a lot. I have a bunch of little arrows acting all the way across the beam, so I'm just going to keep going down slowly. I have a big arrow at the end. I'm going to go up again. And that is my shear diagram. And you're like, well, this can't possibly work for all cases, can it? Well, let's try another one. This is my shear, let's have a point load. Wait, let's have one point load. I'll have reactions again. Right? My shear diagram, what will it look like? I'll go up. I'll start at 0 and I'll go up by this value. I have nothing on this value, so I do nothing. Nothing on this length, so I do nothing. I have another down arrow, so I go down. I have nothing here, so I do nothing. And I have another up arrow, and I go up. And it's that easy. And you're like, well, but we need another example. Okay, here's another example. These are all shear diagrams, by the way. I've done nothing for your moment diagrams just yet. Let's do the same thing, but with 2 arrows. I have 2 reactions still. I draw the shear diagram. I go up, I go down, and I go up again. And this is P, 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 and P. So I went up to P, I went to 0, I went to 0, and I went to negative P. Over here, I went to, this is P, this is P over 2, P over 2. I went to P over 2. I stayed at P over 2. I went down to negative P over 2. And I stayed at negative P over 2, and then I went back up to 0. Now let's do one case with a camel. Let's look at some moment diagrams. Moment diagrams on here. The value of my shear diagram is the slope of my moment diagram. What does that mean? That means that if I draw the moment diagram, I should have a steep slope at the very beginning. Well, notice I have no moment here. At a pin connection, I can't have any moment, right? Like, I mean, if I try putting a moment on this lid, on this pen, it just rotates about its lid. It's a pin connection. It can't resist any moment. In other words, if I take this stapler, on the other hand, and I try twisting this stapler, the top part of the stapler, the whole thing rotates in my hand. Right? This stapler can resist moment. Oh, my hand can try to resist the moment also. And then if I treat it like a pin, it rotates. If I fix my hand, then I suddenly start developing moments. I start off at 0 because I have no moment here. I have a steep slope, so I have a steep positive slope, or a steep positive value, so I have a steep positive slope here. My slope is going to be constantly decreasing until it gets to 0 in the middle, so I'm going to have a constantly decreasing slope until I get to the middle. Then I'm going to have a decreasing negative slope. And a decreasing negative slope means the magnitude of the slope is getting larger. So it's getting steeper and steeper until it reaches a maximum at the end. And this is my moment diagram. I have positive value here, negative value here, I have positive value here. For my other diagrams, this one is a trivial case, I think. I'm not going to do this one, but let's look at this one. I also don't have space to do this other one, so if I look at this, my moment diagram, my shear diagram has a large positive value and it's constant. So my slope here is going to be constant and increasing. I'm going to go here to here. I have no change here, so I'm going to do nothing here. I'm just going to go across. I have a negative slope here, I'm going to go down. Negative constant slope, and I'm going to go down. These should all be straight lines. This other one should be parabolic. Now let's look at the case of a cantilever. Cantilever is like, let's look at a cantilever with a point load at the end. Okay, so now we have reactions here, right? What are the reactions here? I have a vertical reaction upwards, right? And this wants to rotate this way, so I have to have a moment that's going this way. So I need to have, these are my reactions. So what does my shear diagram look like? Well, my shear diagram, I have an up arrow. I should draw this moment diagram in a different color, actually. I'm sorry. So this moment will be blue now. So I have an up arrow here, and I have no change. So I just go all the way across and 0. For my moment diagram, I start off with a, sign conventions are always going to get tricky, but this is actually a negative moment. This is a negative value. I start off with a negative moment. I have a positive shear, right? This is positive. I went up. I have a positive shear value. So my moment should be increasing. My moment should be getting less negative. And it should have a constant positive slope. So I start from a large negative value and I increase till 0. And that is how you draw shear and moment diagrams. Okay, so that is how you draw shear moment diagrams. I'm going to cover the actual aspect of this problem in a second video. So yeah, look for that one if you still need help, if you need help with the problem itself.